In this video, we're going to talk about using the rational root theorem to find all the rational roots of a polynomial. In other words, we are solving these polynomial equations. So there's going to be 4 basic steps that we're going to use to solve these polynomials or find all the rational roots. The first step is to list out the factors, the leading coefficient, and the constant, and determine possible rational roots. And this is exactly what we did in the previous video. The second step is we're going to test each possible root until we find a root, and we're going to be doing this using synthetic division. And here we're looking for the remainder to be 0. When the remainder is 0, we learned that that means that that is a factor. And then step 3, we're going to factor the polynomial using what we found with synthetic division, and then we'll solve the quadratic equation for its roots. Sometimes we might have to repeat step 2 and 3 multiple times depending on the power of the polynomial that we are solving. So let's go through a couple of examples. Number 1, I want to find all rational roots of x cubed minus 8x squared plus 11x plus 20. So my first step is I want to find some possible roots. And so I'm going to label what my p and q is. My p here is 20 and my q is 1. So that means my possible roots, it's going to be p over q. But since my q is 1, my possible roots are really just going to be my factors of p. So my possible is going to be plus or minus 1, plus or minus 2, plus or minus 4 goes in there, 5 goes into 20, 10, and 20. So these are all of my possible roots. Now I need to find just one that is definitely a root so that I can then solve the remaining quadratic. And so what I'm going to do is I want to first test 1. I like to just go in order, so I'm going to go ahead and test 1. And I'm going to do synthetic division. So I need my coefficients. My coefficients across here are 1, negative 8, 11, and 20. And I'm going to do synthetic division, and I'm looking for this remainder to be 0, because then that would mean that 1 is a root of this polynomial. So remember with synthetic division, I bring down the 1. 1 times 1, I get 1. Negative 8 plus 1, I get negative 7. 1 times negative 7 is negative 7. 11 minus 7, I get 4. 1 times 4 is 4. 20 plus 4 is 24. Here, I didn't get a remainder of 0, so that means that 1 is not a factor. So now I'm going to try negative 1. Negative 1 times 1, I get negative 1. Negative 8 minus 1, I get negative 9. Negative 1 times negative 9, I get 9. 11 plus 9, I get 20. Negative 1 times 20, I get negative 20. 20 minus 20, I get 0. So here I did get my remainder of 0, so that means that 1 is negative 1 is a factor. So I can now rewrite this as x plus 1, because my root here, negative 1. And then when I rewrite this, I get x squared minus 9x plus 20 is equal to 0. So now I have this factored, and I'm going to look to see if I can factor this x squared minus 9x plus 20. So I'm looking to see if there's two numbers that multiply to 20 and add to negative 9. And I see I do, that I have negative 4 and negative 5. Negative 4 times negative 5 is 20. Negative 4 plus 5, I get negative 9. And so now I can solve this. So I set each of these equal to 0. I get x equals negative 1. X equals 4. And x equals 5. And so those are my rational roots. So this theorem is great when you can't factor it. So if I were to try and factor this in the very beginning, I could see I could factor out an x from that first pair. That second pair, I can't factor out anything. I see this can't be factored. And so whenever it can't be factored, this method is a good way to find your roots. Okay, let's try one more. I want to find all the zeros of f of x is equal to 2x to the fourth plus x cubed minus 19x squared minus 9x plus 9. So first I want to see what my possible roots are. My p here is 9 and my q is 2. So my factors of p are going to be 1, 3, and 9. My factors of q are 1 and 2. So that means that my possible is going to be p over q. So if I do all my p's over 1 first, I have 1, 3, and 9. And then everything in p over 2, I get 1 half, 3 halves, and 9 halves. So now I need to find some of my roots. So I'm going to first start with 1 and see if that gets me a remainder of 0. So writing my coefficients, I have 2, 1, negative 19, negative 9, and 9. Bring down the 2. 1 times 2, I get 2. 1 plus 2, I get 3. 1 times 3, I get 3. Negative 19 plus 3, I get negative 16. 1 times negative 16, I get negative 16. Negative 9 plus negative 16 is negative 25. 1 times negative 25, I get negative 25. And I see here I'm not going to get remainder of 0. So that means that 1 isn't a root. Let's try negative 1. Negative 1 times 2, I get negative 2. 1 minus 2, I get negative 1. Negative 1 times negative 1, I get 1. Negative 19 plus 1, I get negative 18. Negative 1 times negative 18, I get 18. Negative 9 plus 18, I get 9. Negative 1 times 9, I get negative 9. 9 minus 9, I get 0. So that means that negative 1 is a factor. So rewriting this now, I have x plus 1 because negative 1 is the factor. And then starting back, I have 9, negative 18x, negative x squared, and then 2x cubed. And so now I see I need to start this process again, because now I need to factor out this 2x cubed minus x squared minus 18x plus 9. Here my p and q are the same, so my possible roots are still the same. I've already done 1 and negative 1, so now I'm going to start at 2. And now my coefficients are from this 2x cubed minus x squared minus 18x plus 9. So that's 2, negative 1, negative 18, and 9. You also see that here. So I'm going to bring down my 2. 2 times 2, I get 4. Negative 1 plus 4, I get 3. 2 times 3, I get 6. Negative 18 plus 6, I get negative 12. 2 times negative 12, I get negative 24. And I see that that's not going to give me a remainder of 0. Now we'll try negative 2. Negative 2 times 2, I get negative 4. And then that gives me negative 5, 10, negative 8. And I see it's not going to give me a remainder of 0. Now let's try positive 3. Negative 1 plus 6 is 5. That gives me 15. This gives me negative 3. 3 times negative 3, I get negative 9. And then 9 minus 9, I get 0. So this time I do have a factor, because that gives me a remainder of 0. So that means that 3 is also a factor. So now I have that x plus 1 out in the front still. I now have x minus 3 since 3 was a factor. And I'm left with 2x squared plus 5x minus 3 is equal to 0. And now I'm going to see if I can factor this out. Or you could use the quadratic formula. Either way works. I'm going to go ahead and factor. So this is using the AC method. So 2 times negative 3, I get negative 6. And I'm looking for two numbers that multiply negative 6, but then add to equal 5. And I see it's going to be negative 1 and 6. So I have x plus 1 times x minus 3, 2x squared minus 2x, minus x, plus 6x minus 3 is equal to 0. I can take out an x in this first one, so I'm left with 2x minus 1. I can take out 3, so I'm left with 2x minus 1. And I see I have the same factor of 2x minus 1. And so factoring that out, I have x plus 3. And so then solving each of these, I get the factors of x equals negative 1, plus or minus 3, and 1/2.